So students, today we are going to discuss a very important topic of chapter 14, biomolecules, and the topic is glucose. So starting with the preparation of glucose. There are two preparations of glucose given in NCERT textbook. First preparation is from cane sugar. Cane sugar is basically nothing but sucrose. So here cane sugar, that is sucrose, is treated with dilute HCl or dilute H2SO4 in alcoholic solution. So the reaction follows. So when sucrose is treated with dilute hydrochloric acid or dilute sulfuric acid in alcoholic solution, forms equal amount of glucose as well as fructose. So here this is glucose and this is fructose. Now the second preparation. The second preparation of glucose is from starch. So basically here we are doing the hydrolysis of starch. The hydrolysis of starch is done using dilute H2SO4. So the starch when treated with dilute H2SO4, it forms glucose. Now this process of hydrolysis with dilute H2SO4 takes place at 393 Kelvin temperature and 2 to 3 atmospheric pressure. So when these reaction conditions are applied, the starch upon hydrolysis forms glucose. That was all about the preparation of glucose. Now coming to the structure of glucose. Now the structure of glucose was given on the basis of various observations. So we are going to discuss these observations one by one. So the first observation was the determination of molecular formula of glucose. When determined, the molecular formula of glucose comes out to be C6H12O6. Second observation, glucose on prolonged heating with HI. So this is the glucose and we are treating it with HI and we are heating it for a very long time. So when it is prolonged heating with HI gives N-hexane. This is the structure of N-hexane. So the formation of N-hexane indicates that these 6 carbons which are present in glucose forms a straight chain. The 6 carbon atoms forms straight chain. Now the third observation. In the third observation, the glucose was treated with hydroxylamine. So when glucose is treated with hydroxylamine, it forms an enzyme. This is an enzyme. Similarly, glucose when treated with hydrogen cyanide, it forms cyanohydrin. So these two reactions, reaction of glucose with hydroxylamine forming an oxime, and reaction of hydrogen cyanide with glucose forming an cyanohydrate. These two reactions indicates that a carbonyl group is present in glucose. Coming to the next observation. For the next observation, glucose is treated with a mild oxidizing agent, say for example bromine water. So glucose, when treated with a mild oxidizing agent, that is bromine water, it forms gluconic acid. This is gluconic acid. Now the formation of gluconic acid indicates that the carbonyl group, which we talked about in the previous point, that carbonyl group is present in the form of aldehyde. So an aldehyde group is present in glucose. Now the next point. Glucose when treated with acetic anhydride. So this is glucose. It is treated with acetic anhydride. It forms a pentaacetate product. So here we are having the aldehyde group, and now this pentaacetate product will be formed. Now the formation of this pentaacetate product indicates that in glucose there are 5 OH groups present. Now since glucose is a stable compound, so these 5 OH groups which are present in the glucose are present on different carbons. Present on different carbons. The next point. Glucose as well as gluconic acid when treated with a strong oxidizing agent. So this is our glucose and this is gluconic acid. These both are treated with a strong oxidizing agent, say for example nitric acid. So on oxidation, both these compounds give saccharic acid. Here, this is our saccharic acid. So on strong oxidation, we are obtaining saccharic acid. This observation indicates that in glucose, we are having a primary alcoholic group. Now on the basis of the observations which we have studied and several other observations, the structure of glucose was given as so here is the aldehyde group which we have talked about, and here is the primary alcoholic group. So this was the structure of glucose which was finalized. Now the name of this structure was given as D plus glucose. Now in this name, this plus sign indicates that glucose is dextrorotatory. Dextrorotatory means it will rotate the plane polarized light towards right side, whereas D indicates the configuration. configuration of the lowest asymmetric carbon. In this case, this is the lowest asymmetric carbon. So we will check the configuration of this carbon. Here the OH group which is attached to this asymmetric carbon lies towards the right side. So when the lowest asymmetric carbon has an OH group towards the right side, the configuration given as D. But if that OH group lies on the left side, the configuration is given as capital L. This configuration is similar to plus glyceraldehyde, which is so you can compare the configuration of this carbon and this carbon. Since they are similar, this D is written before glucose. So D plus glucose. The planar structure of glucose that we have studied just now was able to explain many of the properties. But also there were certain properties which were not explained on the basis of that structure. Say for example, first, in spite of the presence of an aldehyde group, glucose does not give Schiff's test. As you all know, Schiff's test is a characteristic test of carbonyl compound. We obtain a red or pink coloration. But glucose does not give Schiff's test. Also, carbonyl compounds give addition product with sodium hydrogen sulfite. But glucose does not form any addition product with this. So these two properties the planar structure of glucose could not explain. Second thing, the pentaacetate of glucose that we have studied earlier, that is this is the pentaacetate of glucose. This pentaacetate of glucose does not react with hydroxylamine. This property or this reaction indicates that we are not having any free aldehydic group in glucose. Then third, glucose exists in two forms. First is alpha glucose, which is having a melting point of 419 Kelvin, and the other form of glucose is beta glucose, which is having a melting point of 423 Kelvin. These two different forms have existence which could not be explained on the basis of planar structure. Since certain properties of glucose could not be explained on the basis of planar structure, so it was thought that maybe the planar structure of glucose can be replaced by cyclic structure. So the planar structure of glucose, which we have studied earlier, is this. So for converting this planar structure into cyclic structure, the OH group which is present at the lowest asymmetric carbon it add up to the aldehyde group which is present on the top of the structure. So when this addition takes place, there are two possibilities. So when this addition takes place, a hemiacetal structure is formed. So one possibility is so here was the OH present. Now that OH will combine with this carbon. This is first possibility. The other possibility for the formation of hemiacetal structure is again this OH group will add up to this carbon through O. Now the two possible structures I have drawn here. This structure where these two OH are on the same side, this is known as alpha glucose. And the other one is known as beta glucose. So if you will compare both the structures, means that the structure of alpha glucose and the structure of beta glucose, the only difference is in the configuration of this carbon. On this carbon, in this structure OH is on right side, whereas in beta glucose on this carbon OH group is on the left side. So this carbon which differs in the configuration is known as anomeric carbon. And these two structures, that is the structure of alpha glucose and beta glucose, are known as anomers. Now, cyclic hemiacetal structures of glucose can be represented correctly in Haworth form. Haworth. In that case, this will be the structure. This is the first hemiacetal structure. This is the other possible structure. So out of these two structures, this one is known as alpha D plus glucopyranose, and this structure is known as beta D plus glucopyranose. This alpha and beta represents the anomeric structures. This D and positive we have already. The name glucopyranose is given because of its similarity in the structure to another organic compound, that is pyrene. This is the structure of pyrene. So you can see in the structure of pyrene we are having hexagonal ring consists of 1 oxygen and 5 carbon atoms. In the structure of glucose also you can see we are having an hexagonal ring with 1 oxygen and 5 carbon. So due to this similarity, the name is given as glucopyranose. So this structure is for alpha D plus glucopyranols, and this structure is for beta D plus glucopyranols. So that's all about the structure of glucose. I hope you understand it very well.